In this video, we're going to look at dehydration, synthesis, and hydrolysis. So this is sort of, before we get into each of the four organic molecules, we want to look at how those molecules are joined together. We talked about the important connectors that actually join monomers into polymers. So let's look at exactly how that happens, or breaks them apart, polymers back into monomers. So dehydration synthesis is what links monomers into polymers. So in a dehydration synthesis reaction, the example that we're looking at here, dehydration, think about the word. To be dehydrated means, if you think about it in terms of you, it means that you're so thirsty that your body is actually short on water. So you're dehydrated, you don't have enough water. So it basically means remove water. Dehydration synthesis, the word synthesis means to create. So by removing a water molecule, a monomer is being created into a polymer. It's creating the ability for a bond to occur. So what is happening here, we have monomer 1, and it has a hydroxide group or hydroxyl group here, and then we have monomer 2, has a hydroxyl group here. So in this case, a hydrogen and a hydroxide ion are joined together as a water molecule and are released in this reaction from the system. What that leaves is monomer 1 and monomer 2 can now share the electrons of this oxygen. And so we have these linked. And notice I said shared, they're linked by a covalent bond. Another example down here, we're looking at a peptide bond. Here's my carboxyl group, COOH. Here's my amine, NH2. In this case, the hydroxide ion joins with the hydrogen ion. They are split off, so dehydration. And what's left, the carbon and the nitrogen, are going to share electrons and form a new bond. So now this was a monomer, and this was a monomer, and they are now joined into a polymer. Hydrolysis reactions split polymers into monomers. So hydrolysis, the word hydro means water, lysis means to split, so splitting using water. So it's breaking polymers into monomers. Here was my monomer 1, linked by a covalent bond to monomer 2 to form this polymer. In this reaction, a water molecule is taken up in the course of the reaction, and it pushes the oxygen away, it splits it, and the hydroxyl now joins back with monomer 1, the hydroxide joins back with monomer 2, and we're back to having two distinct monomers rather than a polymer. So these monomers were linked by a covalent bond, they were a polymer. A water molecule came into the chemical reaction, split that bond, and the hydroxide and the hydrogen replaced the electrons, so keeps them separated, and we now have two distinct monomers.